Hi friends, now let's discuss the all steps which I have told in last class using C++. Okay, I have already imported the libraries which are required. Step 1. Create a color array to store color assigned to all vertices, and vertex number is used as index in the array. So let's take the number of vertices as v. Okay, then we'll create the int array in color array with number of vertices as v. Okay, now the value -1 of color is used to indicate that no color is assigned to vertex. So we'll write one for loop and I equal to 0, I less than the size of array, and I plus plus. And we'll store all the values in this array as -1, right? Equal to -1. Okay. Now the value 1 is used to indicate first color assigned, and value 0 is indicates the second color. Okay, now let's write this into some function. Okay, we'll write some function as bool function. Okay, to return false or true. It is possible to uh, derive the vertices into two disjoint sets or not. Okay, Bipartite of will store array control x control v. Okay, and this will be the adjacency matrix taken input from main function. Okay, like if there is an edge between 1 and 2, then we'll store a of 1 of 2 as 1, and if there is no edge between 2 and 3, then we'll store a of 2 of 3 as 0. Okay, that will be the adjacency matrix. Okay, let's move to second step. Okay, now this is the second step. We have to create the queue. Okay, this is the syntax for creating queue, and we'll take the variable as queue, and we'll push the source vertex. Okay, source vertex means from where we want to start. Okay, this also taken from main function. Now what is this next step in this? Run while loop till there are no vertices in queue. So we'll run the while loop queue dot empty to check the queue is empty or not. Okay, now let's move on to third step. Okay, this is the third step and last step we are going to do. Okay. Now let's dequeue the vertex in queue, and for that we can write, let's take the for taking the top element in queue, and for dequeuing you can write q.pop. Okay. And now if there is a self loop, will return false self loop. Okay, for that you can write, and we took the adjacency matrix as A, right? So if A of u, if there is the edge between u and u, it is called self loop, is equal to 1. I told you, right? If there is edge, we'll take it as 1. Okay, then we'll return false. Okay, now find all non-colored adjacent vertices. So for that, we'll write one for loop. Okay, I will write it. Okay, now I wrote the for loop to check all the non-colored adjacent vertices. Okay, for that we can write A of u of v. So if it has the 1, means adjacency matrix have the value A of u of v as 1, then we can say there is a edge, and we have to also check it is uncolored or not. So we took the color array. If the element in color array is -1, means uncolored, right? Okay, so this implies that if there is edge between u and v and the v is uncolored, then we have to an edge from u to v exists and destination v is not colored, then assign alternate color to this adjacent v. Okay, so let's give the color to v as different color from what it have. Okay, color of u, right? Different color with respect to u, and then we'll push the all elements or all the neighbors of v into q, because we have to check for that also, right? Like BFS. Okay, I hope that you know BFS before watching this. Okay, then last step is an edge from u and v exists and destination v is colored with same color as u, then we'll return false, right? So for this else if there is edge, so for that you can write A of u of v if there is edge and the color of that v index is same as color of u index, then we'll return false, right? Because if it is already colored with red and the neighbor have to color with red, then it is not possible to divide, right? That means we have end up with a odd cycle, so we'll return false. Okay, this is the function. Okay, right? It is easy, right? Okay, now you can give some matrix A of u of v, and let's take, okay, you can give some example, comma int v equal to 4. I'll write it. Okay, okay, take this as example and try it. This one implies there is a edge between 0 and 1. Okay, you can call bipartite of this adjacency matrix and take the source vertex as 0. Okay, thank you guys, please do subscribe.